Hello everyone, today I'm gonna make a video in English. It's the remake of a video that I just did a couple of days ago explaining the cockpit layout, all the instrument gauges, controls of the Cessna 172. I did it in Italian and that was on the classic cockpit with the steam gauges, you know, the classic mechanical instrumentation. These other aircraft has a G1000 avionics suite, I think, the Garmin. And someone asked me to explain it a little bit in English, so that's what I'm going to do. So let's jump on board the aircraft, and here it is. Let me tell you that I don't like this, personally. This is not how a Cessna 172 should look like, but hey, that's what we get these days, and so let's work with it. Okay, so we are on board and we need to make sure that the parking brake is set so the aircraft isn't going anywhere. And here we have the battery, the alternator, and the avionics switches. Before to turn on anything, we want to make sure that all the switches are off, the circuit breakers are all in, flaps are up, mixture is all lean, throttle it's idle, and the key is in the off position. Okay, so let's turn the battery on. Okay, so now this is on because of the standby battery, I guess. It's a small battery that will give you a minimum avionic power, but if you want to turn on the whole thing, then you need to turn on these switches here, and now everything is on. In this configuration, the battery gets drained quickly. In fact, you have warnings here telling us low oil pressure, low volts, low vacuum, because the engine isn't running. So we acknowledge the warning, and now we acknowledge the caution, and then there are some alert. We can pop them up, and we are inside an airspace. Okay, thank you very much. Here we can see our voltmeter saying we are draining the battery, the main and the emergency. We're draining the battery, so we need to turn on the engine in order for that to be rectified. So I guess we're going to turn on the engine, and then I will continue explaining everything else. So we're going to turn on the nav light. I'll come back to this exactly what it is later. The beacon to tell everyone we are about to start the engine. And before we do it, I need to draw your attention to the oil pressure gauge. This is where our eyes need to jump immediately after the engine has started, because if within 30 seconds we don't have this white indicator within the green bar, then we have to shut the engine down. Oil pressure, that's the most important thing. Alright, so we have the nav light, we have the beacon, parking brake is set, we go mixture full reach, we open the throttle 1 inch, fuel pump on, and we can hear it going, and then we're gonna start the engines. Right magneto, left magneto, both, start. And we started. Oil pressure in the green, RPM 1000, that's perfectly fine. 1000, it's what we want. Okay, now we still have low volts, and all the other cautions and warnings have gone. That's good. We turn on the alternator. Now the alternator is charging the battery, and we can see that here it's positive, it's charging the battery. Okay, so everything else is in the green. We can continue with the explanation. Right, so here we have the standby battery check that has to be done. Yeah, now you see that turns on all these cautions and warnings. Still have the alert, and we can arm it. Standby battery. So the test, we also see this green light. These are the internal lights, dimmer, and these are the external lights, the beacon. That's the beacon. The logic of the beacon is we turn it on before starting the engine, and we turn it off after we switch off the engine. Has to do with the engine operation. Okay, is to alert people around that we are about to start the engine, or if we already did, that the engine is running. The nav light, they need to be on every time there is electric power to the aircraft. It's the red light on the left tip of the wing, and the green light on the right wing on the tip, and the white light on the tail. Let's have a look. You see red here, white there, and green here. Okay, so let's continue. We have landing light and taxi light. So landing light is there, you can see it on the left wing. Taxi light, it's next to it, still on the left wing. The difference is that the taxi light is horizontal, the nav light is tilted down some degrees in order to cater for the attitude of the body of the aircraft during landing. Strobe light, you use that when you enter the runway for the purpose of departure, and you turn it off after landing when you vacate the runway, after having vacated the runway. White flashing light at the tip of the wings, there as well, white flashing light. Okay, we don't need that now. We only need nav and beacon. Fuel pump can be turned off after we started the engines. We'll use it again later when we enter the runway for the purpose of takeoff. Pitot heat. That's the pitot. That capture the air, the impact to the airplane, and it gets into the airspeed indicator here to give us the indicated airspeed. Here on the digital one, and also here on the classic mechanical airspeed indicator. Okay. So in icing condition, that will get clogged with ice and we will lose the data of airspeed. So you better have it on whenever you actually fly, because you never know when ice can form. So the general idea is to have it on every time you enter the runway for takeoff, and then after landing you turn it off, especially in winter, cold weather, and visible moisture. So this is the Garmin 1000 avionics suit, and it's too complicated for me to get into any details. Let's now talk about the most important features of this display. It's called the primary flight display, and fundamentally it gives us some flight and navigation information. The main one being the ADI. You see this blue area and brown area, that's the ADI, attitude deviation indicator. That will be the same as this one. Difference is this is mechanic, is a backup instrument. This is a primary instrument, is digital. It's coupled with the gyroscope, and the gyroscope keeps the horizontal line no matter what the attitude of the aircraft. The blue is up, the brown is down, of course, like the sky and the earth. That's probably common knowledge of everyone. On the left we have the airspeed indicator, the tape airspeed indicator, the same as this one, which is the backup mechanical instrument. Here we have the altimeter with the pressure reference, vertical speed indicator, altitude selected, bank angle indicator, sleep indicator here. See the bottom part of this triangle is free and it can move left and right depending whether the aircraft is sleeping. In other words, it is moving around the vertical axis. We have the pitch scale up and down. That will be 10 degrees, 20 degrees, pitch up and vice versa. Down below we have sort of the compass. We can call it ADF, automatic directional finder, with our magnetic heading right here.
same as the compass, but without all the limitation of the compass. We have a little map down to the left, and we can adjust the range of the same this way. We see we are parked in Santa Monica Airport. I'm pretty sure this can be expanded, I just don't know how. We have our HSI. The whole instrument here is the HSI with the course deviation indicator, the nautical miles from the next point if we use GPS, if we use VOR, and if we tune a valid VOR in here, nav1 or nav2. Now it's VOR1, so it's reading this frequency here, 119.9. If we select a valid frequency, then we have a course deviation indicator and a distance in nautical miles if there is a DME. Heading bug that we can change. Oops, sorry, we can change this way as a reference, or also to command the autopilot to find a certain direction. Outside air temperature, ISA, which is the International Standard Air default temperature this day, this month, at this altitude, but the outside actually is 6, so it's actually a deviation from ISA. So 6 degrees today in Santa Monica, this day, this month, is ISA -8, so it's less than what's supposed to be, basically. Selected heading, that's the selected heading, I guess. Yeah, you see, that's the selected heading. This black box, I have no idea what that is. True airspeed when we're flying, this will be indicated, this will be the true airspeed. And vertical speed is 1,000, 2,000 feet per minute climbing and 1,000, 2,000 feet descending here. Anything else? Oh, you can have a flight director. Now this is just the pitch reference bars, but if you turn on the flight director, you will have flight director bars there as well. And these are all the information you get from this display. If we go to this other display, well, this is self-explanatory. You have airspaces, you have VORs, you have your own position there, airport icons, and just a classic GPS map for navigation. Nav signal down there, and you can turn on terrain, you can put on the airways, and so on and so forth. Traffic on and off. So if you turn on traffic and there is an aircraft nearby, it will tell you that there is an aircraft nearby, and the type of icon changes depending on proximity and closure rate. We can turn it off now. So if we turn on topo, that means that topography is off, therefore you don't get to see any mountains or anything. We can go a bigger scale for you to see. Topography there, terrain. That red means there are obstacles at your level. It's a terrain proximity warning system. That's it. These are all the information I can think of in these displays, and now we can move to the other features. You have nav and com frequencies here. You have the direct to indication, the distance, the bearing. Here also you have com and nav. I mean, these are com1 and com2, and these are nav1, nav2. All right. How do you manage that? We'll see in a minute. Here we have the knob to change the frequencies. See there, and then you can swap. You can work on the one below this way and then swap. Okay, for the nav, you go here and you swap, and you can press and work on the bottom ones and swap. Heading selector here, altitude selector there. It goes hundreds and thousands. All right.
The range of the map, you can see the map here, okay, there, and that's the range of the map. Here you have your buttons to manage your flight plan, going direct to. If I go direct to, here you can write an airport. I guess that's the way to write. Yeah, you see KSMO, and that will be this airport, and then you press and you confirm it, and you go direct, activate, and then you go enter, you activate, and you go direct to that point. I mean, but it's complicated. I definitely cannot talk about that now. Alright, so here on the bottom you have a lot of selection, primary flight display, menu, you can choose a lot of things there, and then you go back, and then OBS, you can choose several things about your OBS, 1, 2, CDI, if you want the CDI, that's what I would use. This goes with the navigation frequency, while if you go GPS, how do I go back to GPS? I don't even know. That's CDI, okay, that's GPS. And then it would follow the flight plan that you enter here. Transponder, this is how you manage your transponder. You want to work with the code, there you go. Let's say we have 2000, I want to put 7000. Oops, I don't want that. I want to put 7000. No. Okay, maybe I can only do it this way. 7 0 0 0, and then that's it. And then I close this one up. I would rather like to do it directly here, but it's probably not possible. Local time, nearest airport, and you can go direct. Ident button. Ident button, if you have the transponder, you want to press ident so that the controller sees your icon flashing. To turn on the transponder, I guess you have to go transponder, and then here on, and that transponder is on. If you want alt as well, you go 7000 alt, and then I will go standby, and that's it, and then back. Okay, so this is it with this instrument. This is the COM panel. You can choose where you want to talk, COM1, COM2, which one you want to listen to, the volume, if you want to use the speaker. Most of the stuff in this default aircraft doesn't work. If you want to listen to the Morse code of nav1, nav2, the ADF, you can probably play your MP3 player here. If you want to talk with the intercom in isolation, so you don't want the passenger to hear you, then you can select pilot and co-pilot, something like that. And display backup, I think you have if you have an electric failure, you want to have information that were on the right, you want to have them on the left. You use display backup, probably. Here are the compass, the classic compass, airspeed indicator with all the arcs. If you don't know what the arcs are, the white one, the bottom is the minimum speed, the stall speed with full flaps. The top part is maximum speed with full flaps extended. Green arc, minimum speed with flap retracted, maximum speed in turbulent air. Yellow arc, maximum speed range that you can use in non-turbulent air, in calm air. And the red line is the VNE, velocity never exceed, the maximum speed. You should not exceed that speed. ADI, attitude deviation indicator, the mechanical classic one with the gyroscope behind. You can adjust the aircraft symbol, and this is just a reference mark, and these marks here are the bank angle in 10 degrees each. Altimeter, elevation of the aircraft in comparison to a given barometric pressure level, and we can enter the pressure, the reference pressure here, and we have the consequent elevation versus that pressure level. Now in this case it's 140 feet. If I put it to 0, that will be the pressure existing at the time at the airport level. That's called the QFE. If I put the pressure at the sea level, then I would have the QNH, so it is the altitude which is the separation between the aircraft and the mean sea level. And if I put 1013 or 2992, that's the QNE, is a standard level for aircraft flying, usually IFR anyway, above a certain level. In the United States, 18,000 feet. Everybody has to be QNE, so 1013 or 2992. Mechanical altimeter. Okay, here we have cabin heat, self-explanatory. If you pull it, you're gonna heat up the cabin. Cabin air, self-explanatory. If you pull it, you have some flow of air coming through. Flaps. Everybody know what flaps are, but anyway, let's go outside. These are the flaps. Okay, 3 position, 10, 20 and full, which is probably 45. Okay, do not sleep with flaps extended. Cool, I didn't know that actually. Circuit breakers, like the one you have fuses in the car. They isolate system that they short circuit or they overheat. In this case, they are a little different from the fuses in the car. The fuses burns and then you have to throw it away and buy a new one. These are magnetic. If something short circuit, like a system, it will create a magnetic field so that this pops and opens to isolate that system, but you can always press it in and restore it. Magnetos. The magneto is in the engine and is a device that gives spark to the spark plug. You have selection off to stop the engine, and right, left, and both. And then start engages the starter to start the engines. Parking brake. Static air, pull. It's an alternate source of static pressure. The normal one is outside, but it can get clogged, iced up. If it gets clogged, you select this to get pressure from within the aircraft, inside the aircraft. Then hopefully will be free, and so you can restore the indication in your altimeter and airspeed indicator, proper indication. Okay, you got the trim in there to create a aerodynamic equilibrium in the aircraft. When you fly, there are forces pitching you down or up. If you want to neutralize and zero those forces, you have to act on the trim until you don't feel any pressure on the controls. During takeoff, obviously it has to be in the takeoff position. If you go down, it will force the nose of the aircraft to roll up, to pitch up, and vice versa. Okay, is the hand mic. Doesn't work here, but if you don't have headsets, you can talk in COM1 or COM2 frequencies using the hand mic. Fuel valve. If I pull it now, the engine is gonna stop. That's just a general fuel valve. Fuel tank selector. Left tank, both, right tank. Okay, ELT, emergency locator transmitter. It's a radio that when you crash gets activated and transmit a distress code in a Morse code, SOS, onto a specific frequency, which is 1 to 1.5. You can activate it to test it, leave it in auto, or reset it. The ops meter, this one take count of the hours of the engine running for maintenance purposes. Have I forgotten anything? Oh, that's your tail number, the registration of the aircraft, in this case November 172 Sierra Papa. I think that's it. That's all there is to say, I believe, on the Cessna 172 avionics system and controls and indicators. I hope you enjoyed it. Any question, put them in the comment area below. If you like this video, you can put a like to it. And subscribing to the channel, well, I usually don't create content in English, so if you like, or if you understand something of Italian, by all means feel free. Otherwise, thank you for having not flown with me, but kind of stayed in the aircraft with me for a while. I wish you all a very nice day, and see you soon. Bye bye.